Recall that the three measures of central tendency were mean, median, and mode. The previous video covered everything to do with means, so now we're going to be concentrating on median and mode. All right, let's start out with the median. So the median, which we often use the capital letter M to abbreviate, can be computed depending on two different scenarios. So we're going to use N for sample size just to shorten things a little bit. So if our sample size is odd is our first scenario, then the median, M, is the middlemost data entry. We'll say observation. Okay, just a note on this. Obviously, this requires that you put all the raw data that you get in order before you do anything, because the middle data entry doesn't mean anything unless you do so. Next, what if n is even? Then our median M is the mean of the two middlemost observations. All right, so let's look at an example. It says the price in dollars for a sample of round-trip flights from Chicago, Illinois to Cancun, Mexico are listed below. So what you see right here is a list of, it looks like 7 flights and their prices. So obviously there's a couple large ones there, 872, 782, some smaller ones, right? So the key though is that we are dealing with a sample, therefore our sample size is clearly going to be 7. Lowercase n, remember, is sample size. This then puts us on this wavelength because we have an odd number of observations. So what will the median be according to our process here? It's going to be the middlemost observation, but the only way to determine if an observation is in the middle is to actually put them in order. You can't just take 427. That doesn't make any sense. So the first thing of importance here is we need to put these flights in order if we want to find the median. So what does that look like? Ordered. Our lowest looks like it's going to be 388, so let's just throw the rest in order. Okay, so we have ordered data set, and if we look through this very carefully, you're going to see that this, in the 7 data entries, it's very clearly going to be that 427, just a coincidence obviously from the one up here, but 427 is going to be our median because it's the middlemost data entry. Turns out that it's very easy to locate the middlemost data entry in a small data set just by the symmetry of the problem, because you can work your way in from the outside and be like, okay, so 872, 38, they match up. 397, 782, they match up. 397, 432, they match up. The only one left is 427, right? So clearly we have our median is going to be 427. Now, what happens when you get to a larger data set though, and it's not as easy to eyeball it? Well, it turns out that there is a formula to determine the position of the median that can be very useful. That looks like n plus 1 over 2. So what are you doing? All you're doing is you're inputting your sample size into the formula right here, getting 8 over 2, which is 4. So what does that mean? That means not that 4 is the median, it's that the median is located at the 4th position. So I'm going to write that. So this guy right here, what does that mean? Median is located at the fourth position. So if you look at our data set, we have 1, 2, 3, 4. So look at that, median. Very straightforward. So you're not required to use that formula. You can eyeball it. I'm perfectly fine with that. But like I said, if you get to like 19 data points or 27, whatever it's going to be, like it might be hard to eyeball it. So finding that position of the median might be very useful. Okay, so just to change things up a little bit, let's just say for argument's sake that we're going to remove one of the flights. So let's say you go to log in and into your booking flight website, and you find out that one of the flights is gone. So it's filled. So let's just say for argument's sake that 432 is removed from the data set. So if we put the remaining ones in order, we are going to get, again, 388. We have the two 397s. We still have the 427, but the 432 is gone. So we're left with the 782 and the 872. Hopefully you can see that because of this scenario, our n for this problem has changed. We now have n is equal to 6, which means we are no longer on the upper part of this, but now we're on the bottom. So what does that mean? So in terms of this, whenever n is even, then m is always going to be the mean of the two middlemost data values, which makes a lot of sense, because how are you going to be able to find the middlemost data value? There is none. You can see it's there, basically. There is no middle. So that means the goal is that we need to take the middle two, and we have to find the average of the two. So in this scenario, we'll write it over here. The median is going to be equal to 397 plus 427 divided by 2, just like we normally do average or mean. If we do that, do the math, we're going to end up with 412 as the median in this example, which, yes, is going to be the number that is halfway between these two numbers. But again, let's show you using the position formula. So the position of the median is, again, going to be n plus 1 over 2. That is going to be equal to, this time, 6 plus 1 over 2, which is going to give us 3.5, or 7 over 2. Let me just write it out. 7 over 2, which is equal to 3.5. Now, what does that mean this time? It's a little bit different. So 3.5 happens to be between 3 and 4. So anytime you get a decimal value for this formula, you're always going to take the mean of the numbers that are below it and above it position-wise. I'm going to write that out. So the median is the mean of the third and fourth positions, the value below and the value above it. So again, this doesn't mean anything about the value of the median. It just is talking about how you need to find the actual median itself. So again, let's talk about it. So if we were to look at this and go, okay, this is the first position, second, third, and fourth. So the third and the fourth are the two positions we're talking about. So we need to take the mean of these two values. Well, we already did that. It's 412, of course. We found it. But that is another way to think about it. And again, think about if you had 28 data points. It might not be that easy to find the middle. But if you know that it's going to be the middle of the two middlest positions, and they're actually located on your data point, you could literally count in and find the actual median. So again, this was a good scenario of me giving you an odd number of data points, then removing one and giving you an even number so you can find the median no matter what. All right, so let's take a look at the last measure of center. We call the mode, so that we have done the mean and median already. So the mode basically is going to be your most frequent observation. Okay, so just as an example, really quick, if we go back to our problem that we were dealing with right here, where we had our data points, you would basically look for the observation, in this case, the cost of the flight, which is the most frequently listed. And it turns out that there's a repeated 397 here, which would basically be the mode. There's no abbreviation really from mode that we use, so we would just say mode is equal to 397 from the example up here, right? But there are some scenarios that you want to make sure that you're aware of. If there is no repeated value, then there is no mode, and that should make sense. Like if you don't have a repeat, then you say that. You don't say 0 because there's a possibility in a data set that the number 0 could repeat. So we don't want to go there. We just want to say there is no mode. There could be multiples. So for example, let's say in the data set up there, we had 872, 432, 397, 427, 388, 782, 397, and then let's say 872. So that means that not only do we have 397 repeated, but we also now have 872 repeated. So in this scenario, there would be two modes, 397 and 82. So you would list them out with a comma. But again, if for some reason I went into this problem and I wrote 872 again, then that means we'd be back to making a mode of 872 because now that appears the highest amount of times, which is 3 times.